Hello class. Today we're going to do some review, go over the different forms and representations of quadratic equations, especially the completing the square and how that fits into the big picture. So for today's classwork we have word problems. If you think back, we started this unit with a water balloon toss task that some of you did. Here's the first problem for you to think about. Here's the second. And here's the third. So I'll work through them now, going over the points I think you should pay attention to. As we think back, we have this rule or equation. As a reminder, they give it to us. Y equals x squared plus, really it should be y equals ax squared plus bx plus c. Okay. This thing is going to be your y-intercept. A, b, and c are all numbers. That's standard form. Here they also give you y equals a times x minus 0 and x minus 8. This is known as factored form. These things are going to be your x-intercepts. And for this problem, it asks you, okay, we want to find a, and we don't know what the value of a was. Looks like I'm missing some part. We did need that graph on the second one, so let me go down over here. Zoom out. So this is the graph of that equation. We did need to know, let's see, we need to know a point on there. So let's figure out, maybe we'll use this point over here. Okay, that's 3, 30. Okay. So knowing 3, 30 is on this parabola, we can solve for a algebraically. So as we write, using factored form, y equals a times x minus 0, x minus 8, 3, 30, that's your x and y value. Plug this in. So 30 equals 3, x minus 0, 3 minus 0, 3 minus 8. We get that 30 equals 3 times 3 minus 5. Oops, made one little mistake. This thing should be 8. We don't know what that is. That's what we're solving for. $30 equals a times negative 15. Divide both sides by negative 15. A equals negative 2. So from here, we know now, let me add another page, that factored form for this particular equation, for this water balloon toss for this person, what's her name? Jen, right? Looks like is now y equals negative 2 times x minus 0, x minus 8. What about standard form? So we have to expand this, multiply it out. So to get it, we must expand. So first step, why don't we simplify it? X minus 0 is just x times x minus 8. Y equals negative 2x. That's all being multiplied by x minus 8. Y equals negative 2x squared plus 16. Okay, this thing is standard form. Y equals ax squared plus bx plus c. Notice that a equals negative 2, b equals 0, c equals 16. Okay, and that's all right. We reviewed factored form for a given context. We reviewed standard form for a given context. We see that this is the y-intercept. Here's a graph of the same equation. So from here, there's the point that we selected. I'm going to change colors. Here's the point that we selected, 3-30. Second, I feel like I messed up with the y-intercept. Yeah, I did. Mistake. X, 16x. So then b is 16. C is 0. So we don't have a y-intercept here. There we go. Now this matches up with this graph. So here is 0, 0, both an x-intercept and y-intercept. This point, 8, 0 is your other x-intercept. Along the x, we have yards. And on the y, we also have yards, because we're tossing a water balloon. So visually, we see that on the graph. This is where, where balloon is at the ground. That's what it means in context. We see it nicely in the graph. Other things you should know about graphs of parabolas is this thing down here. Darker color. Okay, this line. Okay, this thing is called x. That equation going up and down is x equals 4. Is your axis of symmetry. Symmetry means if you fold it, it's mirrored, it's exactly the same on the left and the right. This equals negative b over 2a, shortcut. So using the b and the a values from before, negative 16 over 2 times negative 2. Okay, that's how we got positive 4. Here's a shortcut. Then up here, we'll do orange, okay, this thing is your vertex. What's nice about the vertex is it could be minimum or maximum. So in this case, what's this point? 4, 32 is a maximum. The highest this ball went is 32 yards in the air. That doesn't look right. It's probably feet. Let's fix that. Feet. Okay, those are the important parts about a graph. That this is what it can tell you: the x-intercepts, the y-intercepts, the axis of symmetry of the vertex, and some shortcuts on how to get through, get to all those things. So these first two parts are connected. There's the graph. We've reviewed standard form and factored form in equation, and we'll focus more on these connections. So for here, we're starting right with the word problem. It's a little different one that we need a reminder of. Here's Al. So as we sketch a quick graph, sketch, spell, sketch a graph. Okay, so it looks like this. Here, x and y. He releases at 10 yards, lands at the 16 yards. Like that. If the ball has reached a height of 27 yards, what equation? I feel like I'm missing a word. If the ball reached a height of 27 yards, what equation represents this? I think that might be maximum, so let me double check. That might be okay. I think that is a maximum. Max height. That's 27. Like that. And we don't know what this is. Okay. One point over here is that to mention that the axis of symmetry, this line, is always halfway between your x-intercepts. That's kind of where this equation comes in, this negative b over 2a. We need this idea when going here, because now we can figure out where this axis of symmetry is on this thing. Okay, it's going to be at 13. So far, we have that our factored form equation. Okay, we use factored form here because we know our x-intercepts. A equals x minus 10, x minus 16 from the word problem. Now we solve for A. If we know that the maximum here is at 13, 27. 13 came from 10 plus 16 over 2. Right, this is now our point, xy. This is our max, or vertex. So from there, 27 equals x equals a times, we know what x is, 13 minus 10, 13 minus 16, 27 equals a times 3, negative 3. 27 equals a times negative 9, divided by negative 9, a equals negative 3. So our equation here, it looks like this, negative 3 x minus 10 x minus 16. In standard form, we can multiply that out. Negative 3 times x squared minus 16x minus 10x plus 160. So that becomes negative 3x squared minus plus 48x plus 30x minus 580, 480. Yeah, 40. So we simplify that once more. This is our standard form equation. Standard form. Notice we're starting to make connections here. We had to use the idea from sketching a graph, going through factored form, talking about those equations, knowing parts from the word problem, the x-intercepts. Okay. And down here, we go over similar guy, context and a table now. Imp was another player in our game. We have, I should make this bigger. Okay, he tossed a water balloon. Look like this. And from here, we can see, what is it? Let me duplicate. Copy, paste, crop. So I want just this table because I want to extend it. Alright, so with this table here, yeah, never mind. So when we extend this table, we know that over here, when y is 0, that this thing is an x-intercept. We don't know its y-intercept yet. We can tell that this thing likely to be its vertex, because that's when it starts decreasing, right? So from here, it's increasing, and then after this point, it's decreasing. So that's like here, right? Plus and then minus. Like that. That's how you can tell where the x-intercept and vertex is from the table. And you'll notice we have to extend this graph out. Look at our pattern. See that each time, here it grows plus 1. Over here it grows plus 9, plus 7, plus 5, plus 3, and then plus 1. Then it goes minus 1, minus 3, and you can continue this pattern. And we go on to 10, 11, 12, 13, 14. Over here, that's going to be minus 5. So 21 minus 5 is 16, minus 7, that gets you to 9. We notice, oh, the numbers repeat. Minus 11, minus 13, so on and so forth. So this increasing and decreasing is also where the symmetry is present. Let's use a different color. So notice that the numbers repeat. And the pattern in the growth. This is what symmetry looks like. On a table. Okay, that's nice. We found this. From here, we can now find out the equation. Because we now, over here, found the other x-intercept. So, knowing that 2, 0 and 12, 0 are the x-intercepts, factored form looks like y equals a, x minus 2, x minus 12. Using, let's pick, so any point works, it doesn't have to be the vertex. Let's choose 3, 9 from the table. Any point works. To solve for a. Okay. I just chose 3, 9 because those are the smallest numbers, or smaller numbers. 9 equals a. X is 3 minus 2, 3 minus 12. This a value is important. We have to make sure to solve for it because that's like the stretchiness of our parabola. Like that. Divide by 9, a must equal negative 1. X minus 10, x, not 10, it's 2 and 12. Alright. So, one more time, we can turn this into standard form, expand to get standard form. So it makes the y-intercept obvious. Y equals negative 1. Let me just rewrite it once more on this page. I like to do it this way. Boil it out. Or you can draw your boxes here, like that. Okay. And you'll see we'll get the same things. Multiply out the negative 1, negative x squared, plus 2x minus 24, minus 24. Y equals, combine like terms, minus 22x minus 24. I made a mistake in my foiling. This should be 12. This should be 2. As I clean up this problem, there we go. X plus 2. Then our final answer here is positive 14. Okay, there's standard form. Right. And the last thing is reviewing factored form, or the graphing form, or vertex form. That's why we needed to complete the square, right? Vertex or graphing form. General equation looks like this. I haven't talked about this. I talked about it during our first school closure, but since then I haven't. So this is important, right? This is why we're learning to complete the square. One second. Okay, down here. So because from this problem, we already knew the vertex, right, from the table. We know that that's right here, right? Okay, we know that this equation, because this a value out here is shared, right? Vertex form should look like this. -1 times x minus 7 squared plus 25. This is vertex form. For those, this is the same problem, right? This is IMP's table, is water balloon toss. These are 3 ways to represent that same quadratic equation. There's vertex form, standard form, factored form. And we learned completing the square because that's how we get from standard form here to this answer of vertex form. Okay, but there's other ways to go about finding the vertex, as I've mentioned from today's lecture. But just for review, let's just try to complete the square to get from here to standard form, this equation down here. If you were given standard form, okay, y equals negative x squared plus 14x minus 24, okay, we want to change it into a different one. We'll start by moving, say all this equals 0. We'll move 24 over. And then we think, okay, we got negative x squared. Ooh, right, first step, right? Because complete the square, this is where it gets you, and it gets tricky. First, divide out the a value. It only works when a is positive 1 or negative 1. So we divide by -1, divide by -1, divide by -1, divide by -1. Now at this point, we can complete the square. Okay, then we subtract 24 from both sides. We get this equation. We think about what to add on. So our b value here is -14, b over 2 is -7, b over 2 squared equals 49. So that's what we're adding on to both sides. Why? Because now this thing factors nicely back. It should look familiar. See this? And this part. Simplify this end. 24 to 5. I'm like looking over and see if I made any mistakes. Looks good. So now, as we thinking, did I make a mistake somewhere with the sign? I'm thinking it should be negative for some reason. Yeah, should be negative. There we go. Here's the other mistake. This is positive. That's positive. This one should be positive. Makes this one negative. So we actually had to add things to both sides. Shoot, I think I messed up somewhere. I'm not sure where. I'm just in this, completing the square. Steps. B over 2. Where's my mistake? Let's see what happens. 6,393. That's not. X minus. Just from distributing. Minus 24. Divide makes it positive. Subtract. Negative 24, negative 24. Alright. So it looks like I was good the first time. And once we get here, notice we have to move this over, right? So this whole thing equals y. Okay, so then y equals negative 1. Squared minus 25. So, how should I explain that? So, there's our equation, right? But when we put back in our a value being negative, right, that's what flips the sign over. Okay. This one's a little bit harder to demonstrate. Vertex or graphing form. Sorry for taking up a bit more time. I got lost in my work. I hope you were able to follow. So that's today's review.